Hey guys, thanks for tuning in. If you like this video, please give it a thumbs up and subscribe to my channel. That will be much appreciated. In this presentation, we're going to look at the objectives of protections. What are the main objectives of an electrical protection? When we erect an electrical protection scheme, what do we want to achieve? That is what we're going to discuss in this presentation. What exactly are we protecting is the question. This is a fundamental question you ask in an electrical protection, because you just place a device there to protect something. What are you protecting? We have a local protection, which is made of a protection of immediate equipment, such as your substation installations. Those will minimize the disruptions of loads if your system is well protected. Now you have also to look at the time it takes to recover from situations, so that you don't disrupt your load and create abnormal conditions in big cities. Now the larger system issues also, like a city like here is relying on a stable power supply, so you have to ensure that, because the impact on stability of larger system is very huge, usually resulting on economic cost. You also have to ensure on the power quality, because if your power is getting interruption all the time, that will affect on the quality of power you are supplying to your consumer, because your equipment will be unstable. So big cities whose economies solely rely on a stable power supply depends on these objectives of protections to be assured. Failure to protect the system in case of a fault will result in what? In fire. Because if you don't ensure a reliable protections, the integrity of the system will be compromised. As we can see in the picture, this is fire caused by a short circuit, which is a result of a system, a protective system that failed to react in time. Even so, when this happens, you still need to have a system in place that will isolate this particular transformer, which is in fire, from the other equipment, so that you can minimize the damage only to this particular equipment. We are protecting these local installations of your substation. As you can see, this is an aftermath of a fire that's just unraveled an entire substation. You don't want that to happen. If it happened, you don't want it to spread to other sections of the substation, because in a substation, what usually the setup you have there, you might have 3 different levels into one substation. So you got a high voltage, a very high voltage, and a medium voltage. So if you have a fire in your high voltage section, you want to isolate the other sections, and vice versa. As you can see here, this transformer completely ripped because of a fire. What exactly are we protecting in an electrical system? We are protecting generator fault, because a generator is a key component of our electrical system. That's the main component that is pumping power into the system. So if you have an issue with your generator, everything is affected. Your transmission line becomes useless, because your generator, which is supplying power to the transmission line, is not doing it efficiently anymore. So your transmission line just become empty vessels. Expensive consequences for protection failures, because if your system fails to protect expensive equipment, that's a lot of money to replace them. Often electrical companies result in borrowing money because the budget doesn't meet the requirement for replacing expensive equipment. So thus make it very critical to have an effective electrical protection system to protect your local equipment. What exactly are we protecting? Now, in this section, we're going to shift a little bit and we're going to look at what events require protective action. Basically, you can say anything. If there is a malfunction, the system should trip to protect. But what are those events that require electrical protection? A fault, yes. Abnormal operation, yes. So if you have a fault, your equipment probably just got worn out and the contact touch each other that should not have happened, you have a dead short. What exactly are we protecting? Now, the main objectives of protections, as we have seen, are to safeguard the entire system, to ensure continuity of supply, abnormal operation. You have to minimize the damage and the repair cost and ensure safety of personnel. This one here is one of the key features, because you can lose an equipment, but losing a human life usually is a higher cost to pay. So the safety of your personnel is what is a primary concern. So this is why we install devices like earth leakage. Earth leakage unit is there to protect personnel, because you don't want the leakage current flowing from the system in taking a different path, usually the path of the body to earth. You don't want that current, so you must trip if you detect that. But you must safeguard the entire system. All protective system must comply with the following requirement. It must be sensitive enough to detect a fault in an early stage. Oh yes, because a protective system that is effective enough should be able to trip before the situation escalates. And it must be absolutely reliable. Make it simple and effective. It must also be able to discriminate between a fault in another section, like we said earlier. You have a fire in your high voltage section, your system should discriminate and isolate the other sections. Thanks guys for watching. Next tutorial, we're going to look at the qualities of protection, and we're also going to look at some important definitions in an electrical protection system, such as fault current, earth leakage current, earth fault, short circuit current, and stuff like that. So it's important to know all of those. Please don't forget to give it a thumbs up and subscribe to my channel. I thank you. Cheers.